Section 5.6, the last section that we have to do on Chapter 5 other than the review. And it starts off with a series of graphs that are all of a function of the graph of a function of f of x. And we're supposed to figure out the intervals where the graph of f of x is bigger than 0 and the intervals where the graph of f of x is less than 0. To figure out the intervals where the graph of f of x is greater than 0, I'm trying to find the intervals where the graph is specifically above the x-axis. And to find the intervals where f of x is less than 0, I'm trying to find the intervals where the graph is beneath the x-axis. Above, ha ha ha. Beneath the x-axis. And this should be pretty easy to do, because if you look at like a graph like in problem 2, this portion of the graph is above the x-axis. Anything to the left of that x-intercept. And this portion of the graph is beneath the x-axis. And this portion of the graph, again, is above the x-axis. So somehow, the answers to part A, or the answer to part A, needs to be representative of those two regions I drew in blue, and the answer to part B of number 2 needs to be this region that I represented in red. To do this, to get these intervals represented, I need to create intervals more or less the way I created intervals when I did increasing and decreasing. So to answer these questions, I'm going to create intervals, and what I'm going to do is I'm going to start off by drawing negative infinity on the far left edge of my x-axis, positive infinity on the right edge of my x-axis, and then the x-intercepts, the x-coordinate of any x-intercept, and the x-coordinate of any vertical asymptote if there's a vertical asymptote. I'm going to put those all on my x-axis and create intervals. So to get started for each of the problems between 1 and 8, I'm going to mark negative infinity, positive infinity, and the x-coordinate of each x-intercept, if there are any x-intercepts, and of each vertical asymptote, if there are vertical asymptotes on the x-axis. And then I'm going to create intervals . And in this case, because I'm only trying to find out where f of x is specifically greater than or less than 0 without any or equal to's, I'm going to create intervals with all round parentheses as opposed to square brackets. In the next group of problems, we're going to be worried about inequalities that have or equals to, and that will start picking up some square brackets. So I'm going to create my intervals, and the intervals I'm going to create are the interval from negative infinity to negative 5, round bracket, and then an interval from negative 5 to 2, and then an interval from 2 to infinity. Once I get the intervals marked on my graph, I just need to figure out if the interval corresponds to a part of the graph above the x-axis or beneath the x-axis. If the interval corresponds to a part of the graph above the x-axis, it goes in the answer to part A. If it corresponds to a portion of the graph beneath the axis, it goes to part B. Because part A is looking for portions of the graph where the f of x or the y's are bigger than 0, and y's are bigger than 0 when the graph is above the x-axis. Part B is looking for the portion of the graph where the y's or the f of x's are less than 0, and f of x's are less than 0 when the graph is beneath the x-axis. When I go to answer 2A, these two intervals, the interval that corresponds to negative infinity to negative 5, and the interval that corresponds to 2 to infinity, are the regions where the graph is above the x-axis, so those two regions are going to go in my answer to part A of number 2. And when we have two distinct intervals that are part of an answer, usually we separate those with a union sign. For part B, the region that corresponds to the graph beneath the x-axis is the region from negative 5 to 2. So my answer to 2B is going to be the interval from negative 5 to 2. So for each of these problems, I'm going to do exactly the same thing. Just in case you can't see it in problem 1, the x-intercept that I put a dot by there is the point negative 4, 0, and that x-intercept is 3, 0. And in problem 3, the x-intercepts are negative 4, 0 and positive 3, 0. I'll move on and do my problem 4 real quickly. I'm going to mark negative 5 on the x-axis, positive 2 on the x-axis, also negative infinity and positive infinity. The intervals I'm going to create are negative infinity to negative 5, and then negative 5 to 2, and then 2 to infinity. And then I'll look at the region of the graph that corresponds to each. The region of the graph that corresponds to the interval negative infinity to negative 5 is that region. That region's beneath the x-axis, so the y's are negative, so the f of x is less than 0. When I go to answer part this, when I go to put this in an answer, it has to go into a part B, because part B wants the region of the graph that's beneath the x-axis because it wants where the f of x or the y's are less than 0. So part of my answer to part B in number 4 is going to be the interval from negative infinity to negative 5. The next interval, negative 5 to 2, corresponds to this portion of the graph. And this portion of the graph, if I look at the y-axis, that kind of corresponds to this portion of the graph. The y's are all positive. When the y's are positive, f of x's or y's are greater than 0. So this interval goes in part A. The last interval corresponds to this segment of the graph, and that segment of the graph is beneath the x-axis. It's beneath the x-axis, so the y's or the f of x's are less than 0, so it goes in the answer to part B. And because I'm going to have two intervals in part B, I'm going to separate them with a union sign. So there's nothing really to do for the first 8 problems other than look at the graph and figure out the regions where the y's are positive and figure out the region where the y's are negative, and then write those in your answer. So questions, the next questions are a little bit tougher because there's more intervals. The numbers you're going to need to mark on the x-axis for problem 5 are negative 4, 3, and 6. I'm going to mark negative 4, 2, and 7. I'm going to create intervals. I'm going to put the infinities at the edge of my x-axis. The first interval I'm going to create is negative infinity to negative 4. The second interval I'm going to create is negative 4 to positive 2. The third interval is 2 to 7. The last interval is 7 to infinity. And as I go to answer 6A and 6B, 6A is looking for regions where the y's are positive, or the graph is above the x-axis, and the first part of the graph corresponds to the interval negative infinity to negative 4, and then that region, if I look to the y-axis, the y's are positive, so the f of x is bigger than 0. The graph is above the x-axis, so that interval from negative infinity to negative 4 belongs for part A. The next portion of the graph corresponds to this, the interval from negative 4 to positive 2. It corresponds to that region. And in that region, the y's are negative. The graph is beneath the x-axis, so the f of x is less than 0. This is going to go in the interval from negative 4 to 2. The third interval from 2 to 7 corresponds to that portion of the graph. And in that portion of the graph, the y's of each of these points is positive. The graph is above the x-axis, so that's going to go into part A, where the f of x's or the y's are bigger than 0. And then the last part is beneath the x-axis, so the y's correspond to negative numbers, which are less than 0. The graph is beneath the x-axis, so that 7 to infinity is going to go in the answer to part B. Part A is looking for where the y's are positive, or equivalently where the x's, or the graph is above the x-axis. Part B is looking for where the y's are negative, or equivalently where the graph is beneath the x-axis. In problem 7, the numbers you're going to need to mark on the x-axis are negative 2, which is an x-intercept, and positive 3, which is a vertical asymptote. When I go to do my problem 8, I'm going to mark negative 5 on my x-axis for my x-intercept, and positive 4, that's my x-intercept, vertical asymptote. I tried to draw the vertical asymptotes with dotted lines. There actually are dotted lines there. I'm just not sure how well it shows up. I didn't use a big enough thickness on the font for those lines to make them show up. So to do problem 8, on the x-axis, I'm going to put those numbers along with the infinities. The intervals I'm going to draw are negative infinity to negative 5, and then negative 5 to positive 4, and then positive 4 to infinity. It's a little bit harder to see. The region of the graph that corresponds to the interval negative infinity to negative 5 is that region right there. That region's above the x-axis, so the f of x's or the y's are greater than 0. When I go to answer part A, this needs to be part of it, because part A wants where the f of x's are greater than 0, and those f of x's are greater than 0 because the y's are positive and the graph is above the y-axis. The next interval, negative 5 to 4, corresponds to this portion of the graph, and for that portion of the graph, the y's are negative and the graph is beneath the x-axis. That has to go in my answer to part B. The last interval corresponds to that portion of the graph. The y's are positive, the graph is above the x-axis. That's going to go in part A. So that's the first 8 problems. So you should be done with hopefully all 8. And then the next group of problems ask the same questions, but they have an or equal to. When we have an or equal to, then we have to start getting some square brackets and possibly still round brackets. So I'm going to answer the questions very similarly, except any point that's an x-intercept is going to get a square bracket, because I'm trying to find any point that has a y that in part A that is greater than 0 or equal to 0. In part B, I'm trying to find points that have y coordinates that are less than 0 or equal to 0. And the x-intercepts all satisfy the or equal to part. So the x-intercepts are going to get square brackets. In the last group of problems that we did, I was only looking for y's that were greater than 0. And the x-intercepts had y's or less than 0. And the x-intercept had y's that were equal to 0. So they were ignored. And I ignore the x-intercept by putting it in a round bracket. In these problems, I'm allowing y's to be equal to 0, and the x-intercepts need to be included because they have y's equal to 0. So the only different for these group of problems, the only thing that's going to be different is the x-intercepts, because their y coordinates equal 0, will now get square brackets. As opposed to round parentheses. But but the infinities will still get round brackets. As will the vertical asymptotes, because infinities aren't actually points on the graph, and similarly vertical asymptotes don't correspond to points on the graph. So when I go to do problems 10 and 12 that are on this page, I'm going to mark up my x-axis. When you go to do problem 9, you're going to put -5 on the x-axis, +3 on the x-axis, and +7 on the x-axis. I'm going to put -6 on the x-axis, +2 on the x-axis, +7 on the x-axis, and negative infinity and positive infinity. The intervals I'm going to create are -infinity to -6, square bracket now on the 6 because of the or equal to, and then -6 to -2, -6 to +2, double square bracket because those are both x-intercepts and their y-coordinates equal 0, and then 2 to 7, double square bracket, and then 7 to infinity, square bracket on the 7, round bracket on the infinity. So the only difference when you kick up the difficulty and put in or equal to is that then you can't have all round brackets. X-intercepts pick up square brackets. When I go to answer this first region corresponds to a graph that's beneath the x-axis, so that's going to be a part B, because the f of x's are less than, beneath the x-axis, or touching the x-axis, equal to 0. The next interval corresponds to this portion of the graph where the y's are positive. That's going to be a part A, where the f of x's are greater than or equal to 0. The third region is going to correspond to that interval where the graph is beneath the x-axis or touching the x-axis. That's going to be a part B. And the last interval corresponds to this, which is above the x-axis or touching the x-axis, which corresponds to an A. My answer to 10A, the intervals I'm going to choose are the intervals from -6 to +2, union the interval from 7 to infinity. And my answer for 10B is going to have the intervals -infinity to -6 and the interval 2 to 7. (11) and 12 are tricky. The only number I need to throw on the x-axis and number 12 is this 4. And I'm going to create an interval from -infinity to 4 and an interval from 4 to infinity. Square bracket on the 4 because it has a y of 0 and each one of these allow a y to be 0. When I go to do the first interval corresponds to that region. In that region, the graph is above the x-axis and the y's are positive, so that goes in 12A. Second region corresponds to this. Graph is above the x-axis again, so the y's are positive. That also belongs in part A. There's nothing that belongs in part B because there's no part, unless there is something that belongs in part B. I take that back. This is a trick question that I wasn't even prepared for. So the two intervals belong in part A because the graphs are above or touching the x-axis. Part B asks for any interval that's beneath or touching the x-axis. There's no interval that's beneath the x-axis, but there is a point on the x-axis. For part B, which I wouldn't sneak on the test, technically the answer should be there is a point that has a y equal to 0. There's no point that has a y less than or greater than 0, so I wouldn't get a whole interval, but there is a point where there's a y equal to 0. The number 4 probably should be my answer to part B, because in part B, I'm looking for any intervals where the graph is beneath the x-axis or touching the x-axis. I don't get an interval where the graph is beneath the x-axis, but I do have a single point where the graph is touching the x-axis. It turns out that my answer to part A can be condensed. This is actually the same as the single interval negative to positive infinity, because all the way between negative to positive infinity, the graph is either above or touching the x-axis. So when you have two intervals that are next to each other and the ending point of the first interval is in a square bracket, and the next interval has the same point in the square bracket, you can condense those intervals together. You can kind of wipe out the ending points and condense them together with the first and the last point, but that's not really necessary. It was an evil problem. All right, so not 13 and 14. In 13, you need to mark -5 and +3, and it's the same sort of trick. So when I go to do problem 14, I'm going to mark -3, +4. I'm going to create the intervals -infinity to -3, square bracket on the x-intercept of -3, -3 to +4, square bracket on the 4, +4 to +infinity. And now I'm going to create answers. The first region's beneath the x-axis. So I'm going to put it in my answer to part B of number 14. So for 14b, I'm going to have the interval from -infinity to -3. The next interval is above the x-axis, so I'm going to put it in my interval for part A. So 14a is going to have the interval from -3 to 4. The last interval is also above the x-axis, so I'm going to put it in my answer to part A of 4 to infinity. In this lonely point right here is a point where the y equals to 0. It not only belongs in part A, it also belongs in part B, because part B wants any region where the y's are negative or touching the x-axis or on the x-axis. This single point 4 needs to go as part of my answer to B as well. This would be a perfect answer for this. You certainly could condense this interval. If you have two intervals next to each other that are connected with square brackets, that interval can be condensed by slicing out the connecting point and including the first point from the left interval and the last point from the right interval. The answer that I just marked through was okay. It's equal to that, so that's also a decent answer. For 16 and 15, there's vertical asymptotes. The vertical asymptote in problem 15 goes through x equal to -5. The x-intercept goes through 4. In problem 16, the vertical asymptote is at -6. The x-intercept is at 3. When I go to create my intervals, because there isn't a point on the graph above or below the vertical asymptote, you get around parentheses because there is no point there. But a square bracket on 3 because there's a point there that has 0 for the y, and I'm allowed to have 0 here. So the intervals in 16 I'm going to create after I get my infinities down are -infinity to -6, double round bracket, and then -6 to +3, square bracket on the 3, and then 3 to infinity. Nicely, I don't have a turning point. When x-intercepts are turning points as opposed to crossing points, the graphs are a little bit trickier to do. You get these single points in your answer. But in this case, the x-intercept, the graph crosses the x-axis, so I don't have this double intervals together that I need to worry about. So when I go to answer 16a, the regions that are above the x-axis is that region, which is the interval from -infinity to -6. And this region, which is the interval from 3 to infinity. I can't condense those together because the two intervals don't have the same. The ending point of this one isn't the starting point of that one. The interval that's beneath the x-axis is this interval here. And so I'm going to put that -6 to 3 in my answer to part. So you should be able to stumble through 15. And we just have a few more problems. I just had a break, so hopefully that break didn't mess us up. We just 2 more problems, and then maybe I'll put the rest in a part 2. So in problem 17, there's supposed to be a vertical asymptote at -6, a vertical asymptote at -2, and an x-intercept at 3. In problem 19, there's no x-intercepts and there's a vertical asymptote at 0. Let me do your 17 just to get it done, and I won't do my 18. So for 17, the intervals I'm going to create, first interval is negative infinity to negative 6, round bracket because of the vertical asymptotes, negative 6 to negative 2, double round brackets because of the vertical asymptotes, negative 2 to 3, round bracket on the vertical asymptote at negative 2, square bracket on the 3, and then 3 to infinity. When I go to answer number 17A, the regions that are go in 17A are that region which is above the x-axis and that region which is above the x-axis. So 17A is going to have the intervals negative 6 to negative 2 and the interval 3 to infinity. 3 gets the square bracket, everything else gets round brackets. The regions that go in part B are the region negative infinity to negative 6 and the region from negative 2 to 3. Making sure to get the right kind of brackets. When you have the or equal to's, x-intercepts get square brackets, asymptotes still get the round brackets. So I'm not going to do problem 18. I'll do problem 20. In problem 20, there's no x-intercept mark, so there isn't an x-intercept. The only number other than the infinities I'm going to put on the x-axis is the 0, which is where the vertical asymptote is. The intervals I'm going to create are negative infinity to 0, double round parentheses because there isn't a x-intercept there. And when I go to answer 20A, I look for the region that's above the x-axis, which is this portion of the graph. That's where the y's are positive. So 20A is going to have the negative infinity to 0 for its answer. And when I go to answer 20B, I look for the region where the graph is beneath or touching the x-axis. I only get a portion where it's beneath the x-axis. That's going to be the interval from 0 to infinity. So done with the first 20 problems. The rest of the problems are real similar in that we're going to solve them with graphs, but I'm going to need to create the graph and find the x-intercepts, and we'll need to do a little bit of algebra, but they shouldn't be marked much harder.